Thank you. Yes, thanks for the introduction. It's great being in Croatia. It's the first time I've been here. It's a wonderful country so far in the last couple of days, and I'm looking forward to exploring more and learning more about it. So yeah, as he mentioned, I'm going to talk about some issues with security updates. Basically, everyone should know what updates are, but we're going to go into some taxonomy of the different types, and then why they're really important, and then there's been a big shift to try to fix this problem, and then some organizations got in the way of the fix, and we're trying to fix it without going back into the Stone Age. So it should be exciting. Just as a quick intro, yeah, I did the Sealand Offshore Data Haven Co. back in 2000, where we were basically doing jurisdiction-proof hosting, which was an interesting story, and it ended up with a sort of a minor disaster. I lived in this little Caribbean country doing anonymous electronic cash before there was DigiCash and eCash and all this other stuff. I ran a satellite company in Iraq and Afghanistan for a couple of years, actually more like 8 years. And then CryptoSeal, which is a company that used Intel TXT and some of the other Intel security processor features to do security remote attestation for servers, which was pretty cool, which got sold to Cloudflare, and then I worked on security products there. Now I'm doing Reset Security, which is a travel security company. So basically, why do we care about updates? There's sort of a hassle, like you sitting there using your computer, it pops up a window that says, oh, we need to update your software. Every time you turn on a machine you haven't used in a long time, it says, oh, you have like 100 updates remaining. People spend all their time doing patch management, all sorts of stuff like that. Like, why do people care? I mean, there's a bunch of reasons. Part of it's functionality from a security perspective, part of it's 0 days. We've seen some issues where there were internet-wide security compromises. We had the Heartbleed issue where there was this latent flaw in OpenSSL for like a decade that got discovered and suddenly became like patch roulette. I remember getting woken up at some like 2 a.m. to write a blog post about a fix, and it was a pretty exciting time. And we had shell shock, bash bug. We have 0 days that happen all the time. We have Tavis, who's like personally responsible for a lot of sleepless nights on the part of engineers and sysadmins worldwide. I mean, he does great work, but definitely when you see a tweet from him saying, oh, I think there might be an issue in something, everyone pays attention and it's pretty scary. So 0 days are definitely a problem, but they're not the main problem. The number one problem is not really the 0 day, it's the like 30, 60, 90, 365 days. So you have problems where people know about a vulnerability and it exists, and it's in a piece of software that's either widespread or very important. It's either like a control system or it's Windows or some other thing that's out there. And smart people or people that can easily patch quickly. Other people, you look at systems and you have statistics where like 80% of systems are not patched within a week on a lot of platforms. You have a lot of problems where you can look and you see stuff that's been like basically left either unpatched or not fully patched for years. I think the median time now is something on Windows, on desktop client platforms, is something like over 180 days for patches to be applied by like half of the users. So it's definitely a big problem, and I'd say the main problem is this long tail of vulnerabilities that exist. There's a reason why you're not going to use a 0 day for most targets, because 0 days right now, I think the price tag for an iOS 0 day is something like $500,000 US, and for Windows it's probably $100,000 for a lot of vulnerabilities. So if you're attacking a target, you're not going to waste a 0 day on your average target if something that's like 5 years old works just as well. So the main mitigation around this has been updates, and you've got sort of a philosophical issue of whether you want to do pull updates where the user initiates an update and says, oh, update my software now, or a push update where the software schedules an update and reboots the machine, or at least downloads it to the machine and automatically updates it. It's definitely an issue. There's cases where it's a plus or minus. There's also the environment. You have enterprise, you have the mullet where it's business in front and party in the back, but you've got the enterprise versus consumer. So it's pretty different when you've got your single computer versus somebody who's got thousands of client machines to be responsible for. Or somebody, I used to do some stuff with the US Nuclear Regulatory Commission where it's actually worthwhile for them to leave a system, like there's a trade-off between security and reliability in some cases. You don't want to push a patch out immediately if it might have unintended side effects if it's doing something important. So there's some cases where you do want to be slower about your updates, and it's sort of a trade-off that depends on the environment, and you have to build a lot of compensating controls around that. Of course, you've got client versus server. So you have devices, you have especially mobile devices now, you have laptops, desktops versus server farms, and you have different constraints that apply to each. So those are all issues, and it's pretty much we have a current consensus of what the best practice should be. At least this was what it was a few years ago. You'd say that consumers, I think automatic updates have been shown to be the best way. Like it used to be this stuff would never get updated, and you have systems out there like Windows XP that are end of life and are still getting used in both consumer and some embedded environments. Automatic updates probably are the solution for the consumer space and have been shown to be that for a lot of people. But for enterprise, it would be really annoying if you had something that was a push an update to all your machines and it happens during the middle of the workday, because there's this cool thing for a Google Calendar where you can add up the value of all the employees in a meeting and show what a 30-minute outage in the middle of the day for like 10,000 engineers would be. It probably makes sense to schedule those updates for a non-peak time and to do some testing. And then server, of course, if you push a server update to your server farm and it just doesn't work for some minor reason and takes down your entire service, that's not so good. So usually there's a test environment, a staging environment. The same you would do for your own initiated updates, you would do for your operating system. So this is generally the consensus that's been going on, and a lot of people have made there's some arguments about minor things that have happened in the past, but generally this is the consensus. And the nice thing is the move towards software as a service, where you're outsourcing a lot of your IT to third parties, sort of solves this problem for a lot of users. If you're moving to a platform that's more managed, like a mobile phone versus a desktop computer fleet, that solves a lot of the problems for the client devices. And then if you're using something like Office 365 or Gmail instead of running a mail server, you don't obviously need to patch your mail server, just the experts need to worry about it. So that's an interesting thing. And we've got some adoption things that have been great, like definitely iOS is probably the best platform for pushing updates on the mobile phone side. I think the stat is something like within a major release of iOS, you're getting like 90% of devices updated within a month, and a lot of them are updated within days. I mean, sort of that's the case of Apple offering a carrot of cool new features for people, not just security updates, but the updates get pushed really well, and there's some reasons why those happen. And then Chrome, both the browser and Chrome OS are great at updates. They do a lot of incremental updates, and it's pretty cool. So mission accomplished, right? I mean, we've solved this whole update problem. We don't need to think about updates anymore. Yeah, right? Yeah, unfortunately, there's organizations that have decided that the update mechanism is an interesting mechanism that puts a lot of control into the hands of anyone who gains access to it. So there's now some people that have been over the last year or so, a couple of years, rethinking some of the issues and trade-offs of updates. I mean, we've got examples here. We have, I think in 2013, Opera had a key compromise which caused a problem. Apple's had issues where they've pushed, Apple's great, but they've pushed applications out there that did malicious stuff. Microsoft has had the Stuxnet fiasco where they ended up signing the terminal services thing. Flame. Then most recently we had the situation in Ukraine where the #1 accounting package of the country had an auto update server and basically caused complete and utter chaos in the country and moderate chaos globally by pushing some bad updates through a compromise. So the naive response to this stuff, like this new thing that people are doing, auto updates, is bad. So let's just get rid of it and go back to the Stone Age where people leave stuff unpatched for months at a time. Yeah, probably not the greatest idea. Because I remember, it wasn't that long ago, it was probably 5 years ago when auto updates were a very new thing. And enterprise IT was always, the patch management was the #1 concern. It still is actually one of the #1 concerns, but it was sort of a futile battle. And for consumers, you could reliably hack any consumer device because it wasn't updated at all. People are talking about IoT security, and one of the biggest issues with IoT security is it's probably 10 years, 15 years behind the curve on auto updates for a lot of this stuff, and also has a longer deployed lifetime in the field. You have systems that are out there for probably the design life of 10, 20 years. You don't replace your washing machine or your car as frequently as you replace your phone. So without an automatic update mechanism, you're going to have that stuff out there for 15 years. So if right now they decide to add an auto update mechanism to cars, it's probably going to be 10, 15 years before enough of those devices are updated or replaced to have the new update systems out there. So going back to the Stone Age is not really an ideal solution. So what we'd really like to do is retain the ability to do these frictionless updates. And but we also want to prevent two things. We want to prevent sort of the MEDOC situation where you do a large-scale compromise of all users, and you want to prevent the targeted attacks on users. This is not really public yet, but they're definitely have been cases where an individual user had generally within an enterprise, you have an enterprise IT update mechanism that's in place, and that sometimes gets subverted to allow pushes. Generally, this has been in the case of sysadmins doing things. I mean, Bitcoin is a great example. Like the Bitcoin space, I love Bitcoin, it's awesome and everything else, but it's the most exciting part of the computer security infrastructure right now because you can easily monetize a compromise. So if you're looking at what the future is going to look like for general applications in 5 years, look at what's happening in the Bitcoin space today or in the cryptocurrency generally space today. You have compromises where you have insider attacks, exfiltrating, you have extortion, you have ransomware, you have all sorts of stuff that's very, very exciting and very targeted that we've been predicting could happen, but in the Bitcoin space, because you can pull money out very easily, it's happening pretty much. So you want to prevent these targeted attacks where somebody pushes an attack targeted to a given user saying, like run this new version of binary and things like that. The most well-documented cases of that were so Hushmail, this anonymous mail or secure mail provider, served an applet and served applications to users after they logged in. It was generally a secure system, but there was the ability to, if somebody logs in and is an interesting target, you could then serve them a different applet. So there's some exciting stuff that happened there. And the same thing can easily happen in wallet software and all sorts of other stuff. So people have been moving to offline wallets and all sorts of other cool stuff there. So look at the Bitcoin space if you want to see that kind of attack. But just trust me that that attack exists and is an increasing threat. So we've got some ideas on how you can fix this. There's a lot of different things that potentially can fix it and a lot of things that are sort of trade-offs engineering-wise. But yeah, I'd say the first one is sandboxing. In general, when you're pushing a software update for something, it is fixing a vulnerability or it is adding a new feature, and very rarely, if it's you must fix this for security reasons, is it really adding a major new feature or a major new requirement on the platform. So probably what we could do is have a system where you have feature updates, which are not as critical, not as time sensitive, and are much more voluntary for users, can add new capabilities. They can add the requirement to access a new device or something else, whereas simple patches only either keep the same or remove capabilities and remove requirements in the platform. So it would be crazy to have a platform update that's a security update that you push that adds a new feature that requires access to all sorts of local storage where it didn't before and things like that. So companies and software developers and administrators can be more cautious about separating out security from feature updates. I mean, that's my biggest problem with Apple is they roll out a lot of security updates every time they roll a major iOS update. And you have a lot of regressions in functionality for users where on iOS it's not such a big deal, but there are definitely applications where people say, oh, feature X has been removed, so I can't immediately update, or the workflow has changed, especially in enterprise. So really segregating out security updates from feature updates will solve a lot of that problem. And it also lets you have your operating system or your platform restrict what an application can do through like the Android permissions model or the Apple permissions model. Not adding new permissions to these makes a lot of difference. The other thing is sort of three musketeers, all for one and one for all. So you have the idea of to prevent the targeted attack against a given user, make sure everybody gets the same update and make sure these updates are universally distributed. You don't want to have a special binary that can just get distributed to a small subset of users. There's a lot of ways you could theoretically look at solving this. You could publish them through some third-party mechanism, like say the Apple update mechanism or the App Store on iOS or Google Update, where you have, generally you can assume that everyone's getting the same updates, or you can have some other mechanism where you can validate the checksums of updates and just make sure as a user that you're getting the same update that everyone else is getting. This is mostly for the targeted attack, but it's an issue. Then the other thing is the keys that are used for doing software updates. The problem is for a lot of small software vendors, they view like authentic code or they view the Apple signing process as just pure friction from the platform vendor. And especially on Apple iOS where you have like a multi-week delay between submitting updates, it's a pain, and a lot of these people don't really put a lot of effort into securing their update mechanisms. So we've seen a lot of attacks where somebody goes and compromises the software developer on a machine or their keys or something else, and uses that to push out malicious updates to a lot of the user base, most famously in Ukraine. So having a system that secures those keys better, both from physical compromise, multi-party control, things like that, makes a lot of sense. So there's that. There's the assembly line, making sure that this would be reproducible builds. So making sure that there's a way I can look at the source code and know how what the binary is supposed to be, and verify that the source code matches up with the binary that's delivered to me. This especially makes sense with open source software or anything where you've got the ability to audit the source code, either like published source or you have a proprietary agreement with it. The problem is modern computers are really, really complicated, and compilers are kind of non-deterministic in most cases if you don't go through a lot of work to work on it, especially if you don't have control of the build environment and everything else. So it's very hard for me as a user to take the source code, even if I got the source code to like Windows 10, to build that and know that I'm going to get exactly the same binaries resulting as Microsoft got when they built, unless I know the entire circumstances of the build environment. Probably the Tor software is the leader in practical use of reproducible build technology right now. Unfortunately for them, it also means that their build infrastructure is massively complicated and a huge pain. I think moving the industry to the point where reproducible builds are sort of the default and it's a much more streamlined workflow will help a lot with this, because it will then let you verify that what source code changes were made and verify them with the binary changes. The next thing is, of course, audit. Audit is a huge deal. With something where it's an enterprise, you might have an agreement where you're allowed to audit the source code or audit the build process or audit anything else with your providers. With consumer software, there's no way that I care enough or have the access to almost any piece of software I use to audit it. So it makes sense to have third-party organizations that are specialists in this that do audit. I would love to be able to go get a binary and have a signature not just from the software vendor, but also from, say, EFF, saying that the software does not do anything specifically to exfiltrate data in a privacy perspective, or perhaps from an EU regulator that's attesting that it doesn't do anything that violates EU privacy restrictions, or from a specialist software security firm, maybe an automated tool that just says, oh, we've checked for buffer overflows using this particular tool and we have the signature. And then you could have something where the enterprise or the end user consumer can verify that these attestations are made about software before updating. I'd be a lot more willing to update an emergency overnight patch if I see that everyone else is doing the same thing and that it's been inspected by some people that I trust. The other thing would be having channels. So separating out updates. Right now you just get one big update mechanism. In some cases you have a beta channel or a faster release schedule type channel, but it's kind of a hit or miss. Not all software has it. It would be nice to have more segregated updates where you can have your security updates streamed separately from other things. Test and measurement on your software, being able to do evaluations of what the updates do, and knowing the stuff like that makes a lot of sense. It's obvious it's complicated, but there's that. And then sort of the Back to the Future rollbacks. So part of the problem with doing an update is you don't really know what it's going to do. And if it goes wrong, you're sort of making a bet every time you decide to click the update button. Is it going to completely blow up my computer and make it not work, or what is it going to do? So it would be nice to have the ability. I would be much more willing to do something if I knew it could always hit a button and revert to the state before doing that update. Some software does this relatively well, but most software does not. It's a big issue. And then, of course, logging and the ability to, like, on mobile, one of the biggest things that I've started to hate is large companies. Sort of a difference between large companies and small companies. Small companies, when they push an update, generally actually include like a real change log, like either their Git changes or at least they document the features. If you update like the Facebook app or the Twitter app or anything, they say, oh, we've made updates to performance and security on our application. And if you're looking at that, that gives you zero information about whether it's important to update. Apple's also kind of bad about this because there's a trade-off between, if you have a zero-day vulnerability or a generally not widely recognized vulnerability, and your changelog says, oh, we fixed this because of this specific vulnerability, attackers look at the changelog and then quickly say, oh, I'm going to do this, and then target it, and they can do a targeted attack based on that information. So they try to trickle out that information as much as they can, but it doesn't really let you know if you really need to update it. If it's a pure feature update, not so much of a critical need to update in the middle of the night. So there's that. So in conclusion, I think the moves to update, to reduce the friction have been great. Like, we're in a much better position right now, especially on mobile devices, than we have been in the past. We have platforms where you can get 80, 90% adoption on updates within weeks or months. You have a browser platform that auto-updates. You have Chrome OS, which updates everything like almost all the time and is like transparent to the user. And a lot of cool stuff, but because of these organizations that have decided they're going to exploit the update mechanism for their own purposes, there's a risk that we're going to go back to the Stone Age. And I don't know, Stone Age, it would be kind of cool to have this exciting like situation where you can own any box for fun. It's not really the ideal situation. So yeah, so those are the main issues I would say with security updates, and I would be happy to take any questions for the next 5 minutes or so. Great. Okay, thank you. Yeah, so the solution, I don't have a single, like a product solution. I think in general, the solution for users is to push their vendors to adopt those ideas. One is to move to platforms that do auto updates and manage, like I use iOS and I use Chrome OS a lot. And that, if I have something that's a generally high security thing for people that don't have a lot of resources to build, that combination works really well for like 99% of users. There's a few people where it's maybe a targeted issue would be more of an issue, but moving to platforms that adopt those principles works. The problem is then you're giving up a lot of the ecosystem that you already like. Like, I love the Mac OS desktop environment. It's nowhere near as secure as Chrome OS, and if I give up this, I give up a lot of stuff that I like. So it would be nice if those principles and those update mechanisms got adopted by all the platforms. I'm sure people love Windows 10. Windows 10 is actually a pretty decent operating system as a person who used to hate Windows, and they've been pushing a lot of updates in a very good way. So I think getting platform vendors to do that, and then as a software developer, adopting the principle of segregating out your updates and everything else makes sense. Anyone else? Say again, please. Oh, yeah. Sure. Yeah, patch management software. The problem is which ones I would recommend? The problem is there's a lot of them. On iOS, it's fairly straightforward. You can use a lot of the MDM platforms, do a lot of the update mechanism management. Definitely, so the idea with an enterprise is you want to be able to manage updates for your users. There's sort of a trade-off there of letting all your systems, in small organizations or in informal organizations, you end up with a bunch of relatively unmanaged devices just using consumer software and doing updates there. All the other way on the spectrum is you have an enterprise department that doesn't give users any ability to initiate updates and pushes updates automatically. On the Windows platform, there's a lot of Microsoft tools that do management of those things. There are not as many good cross-platform patch management tools that I know about. A lot of these are very platform-specific and very good. There are some commercial ones out there, but a lot of people prefer using free software. I'm not sure what the current best cross-platform solutions are. Generally, what I've seen people do successfully is move to, I mean, honestly, Chrome OS does a great job on patch management for like customer service machines and anything where you don't need to have a lot of heavyweight software running on it, because even I get 90% of my work done in the browser now, and moving to platforms that sort of automate that as a native part of the platform rather than an additional piece of software makes a lot of sense. And mobile is Apple configuration management and other stuff manages that pretty well. But there are some good commercial packages out there that do system management, endpoint defense, everything else. It's usually all tied together. But I'm not sure which ones are the best in each market. Say again? Yeah. I've seen this. I have not looked at it as much as I should. The GitHub Electron offering. There's also something. I believe Facebook is using something that is pretty decent. But I haven't looked at the specific patch management software and things that are pretty good. But yeah, it's an area of active work. There's no single like defined standard out there right now or winner right now. So there's a lot of cool stuff.
Do you think that maybe this view is a bit idealistic because you are part of 2% people that actually care about security and 98% actually just don't want to click on the update? So if you want to make peace and take a middle ground between security and marketing department, because Apple will lose some of their money, they need to employ
Yeah, I agree. This is definitely optimistic. I think the worst case is if we go back to the stone age of not having automatic updates or frictionless updates. The best case is if we can have updates with some level of thought by the large companies. I mean, Apple is pushing device updates to hundreds of millions or billions of devices now, so it makes perfect sense for Apple to put a little bit of extra work into publishing a changelog or into some of that stuff. And for enterprises that are deploying like 10,000 desktops, it makes sense for them to do some sort of staging for their updates, and a lot of them do already. So for the consumer space, yeah, it's definitely a, I don't think we can realistically expect that any individual consumer is going to change their behavior. I think this is all stuff that has to be done by software vendors and by platform vendors to handle that stuff. So. Yeah, that's the biggest problem. I mean, Android is the bad example of how updates work. You have, especially in China, you have a bunch of like Android 2 devices that are out there that haven't been updated in like 5 years or 6 years or something. You have mobile carriers that push out phones and don't release updates, or you have Android itself, which has pretty low adoption on updates. You have updates that are end of life pretty quickly. It's really a problem. You think the Android ecosystem is probably so the legacy Windows XP devices that are still out there are responsible for a lot of problems in a lot of ways. IoT and then Android are probably the three biggest areas of systems that aren't routinely updated that are subject to security vulnerabilities. And unfortunately, Android has such wide adoption, and a lot of the users are it's a huge cross-section of users. So some of them are unsophisticated, so there's no way to expect them to change their behavior at all. There's no way to expect them to mitigate any sort of compromise. And yeah, Android is that the only party that can really solve this is probably Google. Would be putting new requirements on Android devices. The nicest thing about cell phones is the battery sort of wears out after some years, so there's some planned obsolescence in that. That's the only thing that, when I was at Cloudflare, we would look at a lot of the newer SSL features, and the only way to project when those are going to be available is when the batteries die on the old Android devices. So yeah, it's unfortunate. I do think, however, security is important to enough users that they're going to start to, at least people will look at platform. Like a lot of people that are informed at least know iOS versus Android. There are some security advantages to that, usually after a big hack has happened, so it might become a factor. And yeah, cool. And thank you very much.